For problems 12 through 20, indicate if each statement is true or false using the sets defined below. So they're asking us to let the universal set be the whole numbers from 0 to 10. Just pause this for a second and write that set. Okay, so they're letting set A be defined as follows, B and C. So remember, we have to be careful about the difference between what an element means. So is that item listed in that set? This means subset. So every element in the set mentioned on the left of this symbol should be in the set listed to the right of that symbol. This means a proper subset. So it has to be a subset, but the sets cannot be equal. Okay. So with number 12, is 3 an element of set B? So that's going to be true. Okay, 13, 5 is element of set C. Nope, we don't see it there, so that's a false. Okay, and then 14b is a subset of set A. So I can find 1 in set A, 3 is in set A, and so is 5, so that's a true. Okay, 15, they're asking if C is a proper subset of set A. First thing I see that set C has fewer elements, so that's relief. Now I need to make sure it's a subset. So 4 is in set A, but 6 is not, so that is a false. It's not even a subset. Is A a subset of set B? That's going to have to be a false before me even looking at it. A has more elements, and although it's true that they could have written elements in set A more than once, we'll see that 2 is not in set B and neither is 4. Therefore, A is not a subset of B. Is C a proper subset of itself? I don't even have to look at set C, and I know that's false because C and C are equal subsets. So a set cannot be a proper subset of itself. Is the empty set a subset of set B? Well, that's going to be true, and I don't even have to look at set B because the empty set is a subset of every set. So that is true. Is the letter B an element of set A? I do not see the letter B listed anywhere. Notice they did not ask if it was a subset. They wanted to know if letter B was an element of set A, so that is false. Is a universal set a subset of itself? That will be true. A set is a subset of itself. That's true for every set, so that is true. Is a proper subset of the empty set? Well, that's going to have to be false. Let's even pretend that A was the empty set. Well, the empty set is a subset of every set, including itself, but an empty set is not a proper subset of itself. An empty set is a proper subset of every set except for itself. So that's going to have to be false.